This is a really interesting question. If I have unlimited compute to try to build a giant retrieval system to offer like all the word information for my language model, which is sounds like a new version of Google, but if I had unlimited compute, I would just try to do this. Hi, I'm Rulin Shao. I'm a PhD student from University of Washington, and recently I worked on a retrieval augmented language model. And we just had presented a poster at NeurIPS about like a scaling law for retrieval data store. Today I'm here to answer 5 impossible questions wrote by researchers. How do you handle and debug failures in long-running experiments? Oh, well, I think it's pretty painful to debug during my training jobs. So usually I will just say, if I suspect it might be an issue from my data, then probably I sample the data to rerun a smaller scale to debug. Or sometimes I will print some tensors in the middle to see how it works. But usually for a very long-running jobs, it's very important to save the checkpoints so that you don't waste too much time if the error is just happen once in the late training stage. Well, the second question is, if you had unlimited compute, what problem would you tackle and why? This is a really interesting question. If I have unlimited compute, one thing I really want to do is I want to collect all the data on the internet and put in my training data. And also, since I'm working on retrieval-based model, I might just try to build a giant retrieval system to offer all the word information for my language model, which sounds like a new version of Google, but if I had unlimited compute, I would just try to do this. Oh, interesting. So this question says, will LSTMs be the future of NLP? LSTM is pretty good for long-term modeling compared to Transformer. It's more efficient on modeling that, but people have shown that Transformer has a better scaling trends. So it's really hard to say. I would say keeping a state model for the long-term memory will be the future, but it's not just restricted to any certain model architecture design like xLSTM, like Mamba, or a new model transformer architecture design with a memory buffer. They all seem very promising, so we'll see. What are foundation models dramatically less energy efficient learns than human brains? I thought about this question before. So I think one advantage that human brain can be so efficient is they think in a very sparse and structured way. Let's say they don't activate all the parameters they're thinking, but our current model, they just try to use all the resource, all the knowledge they learned during pre-training to do even very simple words. I think in the future, if we want to do more efficient, especially energy efficient, we probably want a better architecture. So it's kind of related to the previous question, what is the future architecture that can help us to do the work more efficiently? And I think the number of parameters you activate should depend on the complexity of the task. So that's my hope for maybe the next generation of model architecture. It's so long. It's if we had unlimited compute power and use all existing data, could current AI training methods create machines with human-level intelligence, or would we hit a performance ceiling? Explain your answer. Yeah, I guess it's a really good question. It's also related to the previous question. I think with the current models, it's just not efficient enough. But if we have unlimited compute, you can just brute force to search over all the existing knowledge, and humans don't understand and we cannot verify. It's hard to say, right? If you don't know the answer, how do you verify if the model is doing correct or not? So I think it's pretty open question. High volume compute, I don't think you can train a transformer to match human brain just because it's not designed to be efficient. It's just we're still exploring how. I think it might saturate someday, and we might always coming up with better solutions. So I'm pretty excited about the future.